The technology behind it is actually a rear projection TV. We've modified it with 4 lasers on each corner. Well, 1 laser on each corner, 4 in total. And what these lasers do is that they project a plane of laser light above the surface of the screen. And when your fingers cross this laser plane, light is deflected downwards towards the camera, and it is picked up, and we do some image processing to find out the corresponding X and Y coordinates.
So the first thing our software does is to have a fully functional VNC viewer. A VNC as in a virtual network computing, which is a remote desktop software that everybody's familiar with. So to be able to use the VNC, you just have to move the window in front of you, and then you can just click like how you would click on a normal desktop with 1 finger. And back to typing here. You can just type whatever you want by just clicking on the keyboard here. And then another feature that we have is file transfer. That's a totally different computer, and you want to transfer 1 file on this screen over to another one. So you will just drag this file over to the file transfer program that we wrote. Let's try a different picture. And same with the windows, you can rotate it and scale it. And if you like this picture, you can transfer over to the other desktop like that.
Here to give you a demonstration of our smart home remote energy automation and monitoring system. What we've basically built here is housed in these little plastic cases are these green electronics which we've designed. We've basically assembled some components on there. We've got a computer, power supply, something called a solid state relay, and the idea is you plug your appliance into this, and then you plug this into your AC outlet. And the idea here is for us to be able to monitor and control the power consumption in the home at the outlet level.
So you can see here, I'm actually wearing a heart rate monitor, if you can believe me. It's a little device on my chest. It is recording my heart rate and wirelessly transmitting to the glove information hub. So as you can see here, the LED that is blinking here is my heart rate. It's actually receiving my heart rate now. And this heart rate information is being sent to the MSP device, which is then sent wirelessly over the Simplicity network protocol to the LCD module. You can see the green LEDs blinking. It just indicates every time that a heart rate is transmitted.
Okay, so this is the LCD module here. There are different menus to help the user set up their exercise session. Here, this is where you can define your target heart rate. So you just simply draw onto your graph. And if you don't like it, there's a clear button here that will clear it. And then here, that graph that I just drew is plotted onto this second graph. And this is where you can obtain real-time heart rate.
As you can see, there is intensity, there is responsiveness. It's a musical instrument. You can express your greatest sadnesses and your greatest joys. If you'll observe, Chuck is the user of the instrument. On him is an assembly including a Bluetooth headset and reflectors to reflect the infrared light. It basically takes infrared light and air pressure produced by the user's mouth as inputs, processes it, and spits out musical notes.
Our design project is Robo, the pool-playing Robo. It's an autonomous robot which basically attempts to make a single pool shot. This is all implemented on an FPGA, as you can see over here. It's the Altera D2 board, and it has a camera that's looking down on the table. And there's a control circuitry for all the motors that are operating the mechanics. And the basic idea is that we just have a camera that's running. It captures an image of the pool table after you've set it up. And then that image is processed to determine which are the pool balls and which is the background.